that we're going to be using as our little brief video notes for Monday, since we're not going to see each other. I want to start by going through a little bit involving the different kinds of notes that we weren't able to get to on Friday. And in order to do that, I want you to take a little look at this graph. Once again, what you see over here is first of all, position versus time graph. You can see that it's curvy. And if you're dealing with a curvy position versus time graph, that means that we're going to be having an object that is going to be changing its speed. In other words, as you're going through, the slope is changing on this position versus time graph. And when the slope is changing, it means then that our velocity is changing. So you can see on our VT graph, we have this velocity that's changing, in this case going from slow to fast, getting faster and faster and faster. In addition, as we're looking at this, you can see that we're looking at and analyzing the meaning of that slope, because everything has physical significance on these graphs. So when we look at the rise on this graph for our slope, the rise is our change in velocity, and the run is our change in time. So in other words, our slope represents the rate at which our velocity is changing, or what we call acceleration, our average acceleration. So that slope tells you how fast our object is speeding up or slowing down. Now, this is a little bit of a flashcard piece, and you can pause this and write this on your flashcards. But when we look at the difference between average acceleration and instantaneous acceleration, we're really looking at what aspect of a velocity versus time graph that we are trying to find the slope of. So if we're looking at the average acceleration, we're looking at the slope of that secant line. So on the VT graph, you can see this is a curve. Oftentimes it's linear for us, but in this case, just to kind of drive home that point, you see a curve. It means our velocity is changing, and it's changing at a non-consistent rate. And specifically, you'll see then that when we look at this connecting of the dots between two times over a certain time interval, and we find the slope of that line, we're able to find that average velocity. Now, instantaneous velocity is saying at one instant in time, at one point in time, what's that acceleration going to be? And the way you do that is at that one point in time, that one instant in time, if you find the tangent line to that curve, and you find the slope of that tangent line, you're able to go and find the instantaneous velocity. So once again, instantaneous velocity is that tangent slope, whereas the average instantaneous acceleration versus the average acceleration, which is going to be the slope of that secant line. Now, once again, you can go and plug this in on your flashcards. For acceleration, we're looking at our change in velocity over change in time, which we can expand out to be final velocity minus initial velocity over the time interval that we're looking at. And in AP terms, that change in velocity is actually V minus V naught. V minus V naught. Now, we also went over and we looked at a couple problems, and these are in the notes that I sent to you guys. First of all, on problem number 20, when you're looking at this, you're seeing a ball that's moving into the left, into the wall, and then it bounces off the wall and heads back in the other direction. The key in this case is that you want to draw a picture, and you want to identify what direction is positive for you and what direction is negative. I called to the right positive, and then I called to the left negative. So based on my picture, since I'm moving into the left first, I have a negative initial velocity, and I'm moving away from the wall at the end, and that's a positive velocity. And then you use your change in velocity equation, plug that in over that very small time interval, and you get an acceleration of 15 meters per second squared. Now, you can see up here that this is negative in the answer that was listed on here. The idea is that it was flipped, okay? It's all about how your velocity is changing and the direction of that change. So let me expand on this a little bit more by flipping back over to my iPad. Now, this is the same problem that number 20. If you're looking at this and you're seeing an object that is, first of all, for my purposes, it's going to be moving towards the wall. So I had my object moving over here to the left, and my acceleration was going to be positive, right? We end up getting that positive value. Now, when you have this happen, where your velocity is moving to the left and your acceleration is moving to the right, it causes your object to slow down. So it's slowing down while it's moving in in this case, to the left, which we are calling negative. So it's slowing down as it's moving to the left. Now, after it hits the wall, it's moving in the other direction. It's moving to the right. And since my acceleration is in the right, it's causing my object to change its velocity and get larger and larger and larger. In other words, speeding up as it heads in the positive direction. Now, all this slowing down and speeding up stuff is happening over a very, very small time interval. So it's a little harder to conceptualize this. So what I want to do instead is take a little look at an example here. This is an example involving a bowling ball rolling on the ground. There is an object that maybe you're pushing on the object and you're pushing on the bowling ball to the left, and it causes this acceleration. So we're saying at time 0, it has an initial velocity of 6 meters per second. Now what you'll see is that I actually have expanded this acceleration of -2 meters per second squared to be -2 meters per second per second. The idea is that when you're talking about a velocity, acceleration, you're talking about the change in velocity over change in time. So actually this acceleration is -2 meters per second over 1 second. So what does this mean? It means my velocity is changing by -2 meters per second every second of motion that passes by. So after 1 second, because this is a -2 meter per second change, it's causing my velocity to go down to 4 meters per second. After 2 seconds, it loses another 2 meters per second out of its velocity. After 3 seconds, it now is at rest. And in this situation, it's actually going to be at rest just for one brief instant in time, and it's going to cause it to change direction. So as it's losing now, it's losing its velocity for the first half as it's slowing down. Now, because the acceleration is negative, after it's at rest, it causes that ball to change direction and start to speed up in the negative direction. So after 4 seconds, it's moving at -2 meters per second. After 5, -4 meters per second. After 6 seconds, it's at -6 meters per second. Once again, this first portion is causing it to slow down when the acceleration and the velocity are in opposite directions. And then for the second half, it's causing it to speed up when the velocity is in the same direction. I'm sorry, I flipped those around. When my velocity is in the same direction as my acceleration. Speeding up when they're pointing in the same direction. Now, I want to show you a little bit about a cart down ramp experiment. And this lab is one that you're not going to be collecting data on, but you're going to be given information. And I want to use it to be able to help us develop the acceleration equations that we're going to be using. So, let me hop over here. I'm going to show you a little video real quick to represent what this looks like with a cart heading down the ramp. So with this experiment, what we actually have is we have a motion detector that's going to be posted up here on the top. We have the cart going down the ramp, and you collect your data based off of that cart moving down or away from your actual motion detector. So with this in mind, let's see if we can go in and figure out what this is going to look like. So think about your graphs. Think about your graphs and what you'd expect these graphs to look like based off of our knowledge of motion. So objects speeding up as it heads down the ramp. Oh no. There we go. So what we're seeing is that this is the position versus time graph for that cart. And you can see that from here to here, you have a curvy portions. This is when it's actually moving down the ramp, speeding up in that positive direction. So speeding up in the positive direction. What we do then is we go over and we get a curve fit. And we click on our quadratic, we try our fit, and what you'll see is that when we do that fit, that we have this quadratic piece, this curvy, quadratic nature, and it gives us our constants, our A, our B, our C. So I'm going to click OK, and what you're going to see then is in the sheet that I give you and in the data that I present to you, and that's available on our Google Drive, you'll see that there's data that I'm going to give you for the A, the B, the C coefficients. Now, with those values, we want to now look at the velocity versus time graph. And you'll see that during this portion of the graph, which is actually what corresponds with that same portion on the position versus time, when the cart's going down the ramp, you'll see that it's kind of pretty linear. It's pretty linear. So we have a linear portion of this graph, and we're going to go through and find our velocity versus time and go and record that. Okay? So once again, velocity versus time, we have our slope and our y-intercept. And we do the same thing then for our acceleration, except in this case, you see that it's pretty constant. our acceleration is pretty constant. So what I'm going to do then is go through and get you a mean or average acceleration value. Now, with this in mind, I want to go through and do a couple more things. Now, with these particular objects and with these graphs, what you're going to be able to get them is you're going to go over to your AP Physics folder in Google Drive. Go down over to Kinematics, go to Handouts, and then there's going to be a portion of your of this here on your file. Let me see if I can find it. Here we go. Cart down ramp lab data provided. So you're going to click on that, and you'll see that you'll have examples of these graphs with that data on there. Same with the VT, same with the acceleration. And then you have a little worksheet. On this worksheet, what I'd like you to do is go through and describe the shape of those graphs. Then you're going to go through and you're going to enter in the variables. What was on the y-axis for the position versus time graph? What was on the x-axis? Same thing for the VT graph. What was on the y-axis? What was on the x-axis? And then you're going to write down those coefficient values that were listed, the slope and the y-intercept, and then also the mean value for acceleration. And my goal is for you guys, before you come back on Wednesday, to go through and see if you can find patterns. Where do you see these numbers at other points on or within these equations? And as you're looking at the y-intercept, the b, the a, once again, the y-intercept, the slope, and another y-intercept, see if you can find the units associated with these particular coefficients, and then identify the physical meaning. Our ultimate goal then is to fill in the general physics equation. What general physics equation are we going to use to represent our object's motion when it's accelerating? Now, one last piece. Let me flip back over to my iPad real quick so we can show that. We have with this then one last piece that I want to kind of point out here. So you got that from the Google Drive. Here's a homework. I want you to do WebAssign. These are the ones from the weekend. We've had some WebAssign issues, technical difficulties, which just know I am very, very frustrated to just work with me, communicate with me, and I'll make sure we can do extensions. And in this case, because WebAssign's been a little funky tonight, we are extending that until Tuesday at midnight, so don't worry about any extra WebAssign besides finishing up the ones from this weekend. Also, I want you to do that cart down ramp lab, see if you can identify those general equations for the accelerated motion, and then just review 2.6 in your textbook, which gets at this whole idea of equations associated with accelerated motion. So once again, WebAssign, finish that up. Oh, also, as just a little side note, if you want to do your retake quiz, that is available on WebAssign. So to take your retake quiz, you have your 10 attempts on there. There's homework and helpful hints kind of posted on there for that assignment. And please do that by Wednesday. By Wednesday, crank that out so we can get your grades up. Like I said, my main focus through all of this is for you to learn and make sure you know what you're doing. So as you're doing your retakes, work through it, make sure you ask questions so that you can learn more about it, and then your grade will represent and reflect your retake score. So without further ado, I hope you have a super awesome Monday. And oh my goodness, I went a minute and a half over, so I apologize for that. Have a great evening, and talk with me and let me know if you have any questions. See you Wednesday.